Trying to think of what, oh, and we're recording. Awesome. Thank you, Tracy. So I'm wondering, a lot of names I recognized from last week. Just maybe by quick audio, is there anybody here other than Tadjo that I already talked to who is here this week but was not here last week?
Me.
Me.
Yeah, same here.
Okay, so that's fine. It's no problem at all. So just to give a quick little recap, done a couple of things that will hopefully make life a little bit easier. The first is we've created a new Slack channel that we're calling Algorithms SG. You give credit to Kinlan for coming up with this idea. Some of you may have already been on the career hacking channel, and we decided to go ahead and put a separate algorithms channel out there so that, because this is a relatively narrow topic in the grand scheme of technical interviewing, and so we didn't necessarily want to hijack the career hacking channel to have all these conversations about algorithms and ideas and trials and tribulations that people may be having. So we've created this new channel. Check it out. We put the notes from last week's discussion are there, and I think Kinlan's also made a link to another Google Drive. So kind of intending for this to be sort of a repository to help kind of keep us organized. In the meantime, to catch the new folks up, last week we just went over what QuickSort is conceptually. As a recap, it's one of your divide and conquer algorithms. So, you know, we've talked about this all the way through Learn so far, no matter where in the program you are. There's constantly this push, especially when you're doing some of the labs with a lot of the larger test suite. Instead of trying to do the entire lab all at once, you just break it down into smaller bits. And you just keep going into smaller and smaller bits until you get to something that you can solve. And QuickSort is a very similar approach for sorting an algorithm. So you're going to take your really large algorithm, you're going to sort it based on a pivot value. The pivot's going to be one element in that array, and you use it to divide your first array into like two subarrays, where the left subarray is all of the values that are less than the pivot, and the right subarray is everything that's greater than the pivot. And you just keep going through this. So once you have your left subarray, you pick another pivot, you do the same sort and the same sort until you get down to arrays that only have one element in them, which by default have to be sorted, and you push everything back together. Okay, so we kind of went through that couple of iterations in Ruby and how my attempt at QuickSort compares to Ruby's native sort, which is actually a very optimized version of QuickSort. Then we kind of left it with, hey, there are these problems out here on HackerRank, and let's take a look and see, based on what you know now, how you feel about these problems. If this is something that you think you want to dive into, kind of get a little bit more comfortable looking at code and talking about code, that kind of deal. So with no more ado, I'm going to go ahead and share my screen. So hopefully the first thing you guys see is this new channel, Algorithms, which looks like a lot of you guys have joined, which is good. Move some of this sharing stuff out of the way. Then we'll go over here to these QuickSort problems in HackerRank. So unless there are other ideas, and I'm totally open to any ideas anybody may have, because I'm just the tour guide here, I thought we could just dive right into problem number one. Anybody who was able to solve it, anybody who looked at it and was like, what the hell is going on here? I feel worse than when I started, because that's not the point. We want everybody to feel really comfortable and really confident with what they know, because no matter where you are in the program, you know more than you did when you started. So with that, anybody want to take a stab at talking their way through QuickSort 1 and partitioning, if they were able to figure it out? Any issues they had, approaches to kind of figuring out workable code? Don't all talk at once. Anybody? feel like I'm going to be calling on Ferris Bueller here in a moment. All right. So to help break the ice, this is the one that I could figure out. So these are definitely tricky. Some of you may have participated in a code challenge that HackerRank was running over the weekend. And I tell you, looking at some of these problems is definitely a humbling experience. So if nothing else, maybe we can just kind of go through this and I can tell you a little bit about how I broke it apart and see what you think. Sound like a plan? Okay, I see a couple of heads nodding, so that's cool. So they give you a little bit blurb here. I kind of ignore this intro paragraph because, you know, that's just my style. It's not really relevant, but it's basically saying, you know, here's your challenge. You're going to be given an array, and you're going to be given this element P, which is your pivot, which it wants to be the first element in the array. And then you're going to partition this array into left, right, and equal pieces using these divide instructions, which is what we had just kind of gone over with. This is the basic divide step in QuickSort. You pick a pivot, and then you break your array into a left side where everything's smaller than the pivot, and a right side where everything's greater than the pivot. And they've got this equal step, but as you'll find a little bit later here, all elements will be unique. So there's no chance of having a value that's going to be equal to P, but we'll ignore that for the moment. Okay, so once you divide up this array, and it wants you to print out everything that ends up in the left array, followed by every element in equal, which we know is going to be the pivot, followed by every element in the right. And you need to do this on a single line, and each one of the numbers need to be separated by space. Okay, so any questions or confusion on comments on what exactly it is that we have to do here? Okay. The next deal with these HackerRank challenges is they usually give you some information about how the input is going to be. To be perfectly honest, I'm more of a visual person. So I read this, but my brain processes it a little bit like Charlie Brown listening to his teacher. And I see the words, but I'm kind of thinking wonk wonk until I get down here and I see the sample. And all of these HackerRank questions have samples. So it's telling me the first line of input is going to contain a number that represents the length or the size of the array. So that's this number 5 here. And then the second line is just going to be all of the numbers that are describing that are in the array. So these are all of the elements. And the reason why some of this looks a little bit strange, and I'm a little bit like, well, why don't they just say this is the array? For those of you who aren't as familiar with HackerRank, you can solve these problems in any language you want. And so what counts as an array notation for Ruby might not be array notation in Java or in C++ or that. So they kind of do a little bit of this stuff up front. So this is just 5-member array. Here are all of my numbers. Gives you some constraints, and this relates back to the test cases. And then it gives you a little bit of like, here's what we want the output to look like. So this is just doing that whole single line. Give me all the numbers to the left and all the numbers to the right with the pivot in between. So before going, and then they'll give you a sample input output and some explanations, but before we go any further, if this is the sample input, and trying to get all this on one screen, and you know what the challenge is going to be, somebody want to give me what value in our array has to be the pivot?
Was it 4, the first number?
Yes, it is definitely the 4. Because it tells you, and who was that speaking? Just curious, Silly.
Kelsey, sorry, I was eating, so I stopped.
No worries. Hey, Kelsey, that's awesome. So yeah, it tells you that it's got to be your first value, and they're feeding this information into you in order. So 4 is going to have to be the pivot. So, and then the next thing that comes in these HackerRank challenges is going to be a little bit of information explaining how they went from input to output. So it's telling you here, if this is your input, you're going to read that as your array. Our pivot, as Kelsey pointed out, it's going to be our first value of our first element of 4. And then we're going to start with a left, equal, and a right arrays where the equal array is going to contain the pivot. And then it just kind of goes through saying, all right, well, now I'm going to work through it left to right, just like we did last week, and decide which one of these left or right arrays am I going to put this in. So first number is 5, 5 is greater than 4, so it's got to go to the right. Next number is 3, 3 is less than 4, so it's got to go to the left, and so on until we get everything filled in, and we've got our 3 and 2 over here, 5 and 7 to the right, and then the pivot's in the middle. I want you to print out the elements, left, pivot, right. That's how you get your output, okay? And then it goes on to say, because this particular challenge doesn't require particular sort order, this isn't the only correct answer. You could also have this guy where all the numbers are sorted would be a correct and viable answer, okay? Just a constraint for this particular problem. So, awesome. So it wiped out all of my code. So when you scroll on down here, you'll see all HackerRank stuff needs to be done in their own editor. You can upload code if you've written it in Learn's IDE, or if you're using Atom or Sublime or Tracy, what's the new one that all the cool kids are playing with right now?
VSC. Yeah.
Yes.
If you scroll to the top, your submission might actually still be up there.
Scroll to the top of what?
Of that page.
Upper right.
Yeah, go all the way up to the top, and if you see submissions, your submission. Yeah. It's
No, I can pull that back, but I thought maybe we'd just go through this one.
Okay.
Awesome, thank you. Good reminder. But this is kind of what it's going to look like. So you can code locally and upload, or let me shrink everybody down here. Or you can come over here and use your own compiler, and you can choose whatever language you want, including languages that honestly I have never heard of. So I got mine set to Ruby. It's going to pre-populate with a couple of things. It wants me to write this function partition where I'm being passed in R. And if you're not sure what it's passing, you can kind of tell based on the rest of this fun script that it's giving me. R is going to be standard in, is just user input. Basically, it's feeding this in automatically when it runs the code. It's gonna, and you may have seen some of this notation before. Gets just pulls from standard in. Chomp gets rid of all the white spaces. Split's going to split followed by this space. It's going to say take whatever that input was, which you'll remember looks like this. And everywhere you see a space, split it. Map, if you're not familiar yet, is one of the standard Ruby functions to collect and return an array. So it's saying, and this is just your block notation. So for every number that we pass in that's been split on the space, convert it into an integer. Because remember, what we're putting in initially, because we're just typing it on the keyboard, those are all just going to be strings. Or in this case, it's just coming out of a text file that HackerRank's got set up somewhere. So this is how we're generating our array. And then we're going to pass that bad boy into our function that we need to define. So, because these are much more fun when they're interactive. Anybody want to start thinking about some elements that we might need in this function? And I will say up front, HackerRank's very forgiving. You can run your code over and over just like you can in Learn and see if it passes. Usually give you at least one test case. So throw out your ideas. I'm going to say anything anybody wants to type in here, I'll go for it. But don't all speak at once.
I think you need to set up variables to house your left, equal, and right.
Sure. Okay. What do you want to call it?
Left, equal, and right.
Okay. And what do you want them to be?
Just empty array, equal, square brackets.
Awesome. All right. Now what? As a reminder from the challenge, it tells you you're going to be given an array, and it tells you what your pivot needs to be. And then based on the array and the pivot, partition into left, right, and equal. And I'm going to actually see if I can copy these instructions down here so they're easier for us to reference. Oh, yeah, that didn't work. So let me just type out a small set. Okay. All right. Anybody got some ideas? Feel free to chime in. Let's keep some. Don't worry necessarily about code. Just think about it in one of my old college teachers used to call it the Queen's English. So I bet all of you know what you need to do if you just needed to talk it out. You may just not necessarily feel like you have the Ruby for it yet, which is fine. Start with the English.
Okay, I guess I'll give it a shot.
Awesome.
So we definitely want to iterate through the array. So we should start with AR dot each or dot map. Just used to using each. Are they both exactly the same? Like
they're not. They're both iterators. The difference is in the return value. Each returns the original array, and map will return the new array based on the iteration.
Okay, so maybe
in this case, each works just fine.
Okay, we might want to maybe use map though if it returns a revised array. We'll find out. And then you can do so yeah, ar.map do, and then you can put the replacement argument to be yes x.
Okay.
And do if x is less than 4, because that's our partition. Is that the name that we're using? The
pivot, actually.
The pivot. Okay, my bad. If x is less than 4, append. So yeah, new line after that. Put left. Left as in for the array, and then do the append symbol. Append x, and then we can do a new line saying else if x equals 4, or actually no, sorry, my bad. Else if x is greater than 4, then you can do write and then append x.
Mm-hmm.
And then the final line is else just append equal append x.
Awesome.
And then end.
Oops. Let me get my cursor back in the right place. And then an end on the loop.
And that's all I've got.
No, that's actually a great start. What do you guys think about this?
So this is actually something, I would just say something that confused me just looking at this for the first time is that I would have assumed that the partition would have taken 2 arguments, the array plus the pivot. So the pivot's just hard-coded at this point to 4?
The pivot is currently hard-coded, which might be something that we want to revise before our final solution for this particular challenge.
Okay, cool.
So, but does, this was one, right? Does this loop make sense to everybody? Do you understand what the iteration's doing?
Yeah. But would you want it to be x to be greater than whatever index 0 is instead of hard coding it to 4?
Yeah.
That's a good replacement. Yep, that's a good idea.
Okay, so how could we do that?
I think we're gonna have to do the map with index. Is that I know I've done each with index. I don't know if the same can be implemented with map.
It can. Well,
Okay.
so talk me through what is that going to buy you? What are you going to do with that?
It'll put a second argument next to the x that we have at the beginning for do, and then the second argument could be the index.
Like this?
Yeah, and then it could be y, or yeah, I makes more sense. And then, so I guess we could do for first if x is greater, or actually no, if I equals 0, or no, or we could do, I don't know, you guys want to help?
No, you're good. You're heading in the right direction. This is maybe for me. This is maybe not where I would head, but I see where you're going.
Okay.
Just keep talking it through. And anybody else who sees something, chime in.
Maybe we just need to make pivot a variable. So pivot equals the index of array 0.
Okay. And where do you want to do that?
We could do it underneath right. Just do it at the top. That way it's not that way it's in a variable. It's not referencing that array every time. If we were to do it down below.
All right. So like this.
Equals array 0. Yeah.
Okay. All right. And then what would we? I guess replace the 4 here with our new variable.
Yeah, that works.
All right. How do you guys feel about that? I definitely like this variable idea, because then that means that now we're not restricted to whatever, because when we were hard coding it, remember, this is just one test case. So if we were passed a different set of numbers, it would still be trying to set our pivot at 4, and 4 might not even be in our array. So I definitely like this approach. How do you feel about the loop?
I don't think we need the with index anymore.
Okay. Other thoughts? I would generally agree with that, but I'm just, I got one way to look at it, but one of the beauties of Ruby is that there's lots of ways to skin the kitty. So.
Yeah, I personally wouldn't use the index at the moment.
Okay. All right. So why don't we, let's put it back to the map we had before.
Yeah, because the index would just be passing in the index of the element of the array. So every time the index would go up by 1, so you wouldn't need it.
Right. Right. All right. So I'm just I'll change my comment here.
Do we really need to use the equal array since all elements are unique?
Say that again. It was a little bit, the sound came through a little muted.
Do we need the equal array since all elements will be unique?
Good question. Okay, so I'll definitely take a group survey on this one. My personal opinion is no, because I feel like all the elements are unique, so by default it has to be equal to the pivot. But since the problem calls for outputting left, equal, and right elements. I'm a little bit 6 of one, half dozen of another. What do you guys think?
Wait, so what's the alternative of not having equal?
So, so not having equal means we're going to have to keep track of this pivot somehow. So what we can do is we can leave it in for now and kind of finish the problem out so that we can see what maybe the fullest solution would look like. And then when we have something that's passing HackerRank's test cases, we can come back to this and see what happens if we take equal out.
Okay.
Does that sound like a reasonable plan?
Yeah.
Right. But yeah, I'm kind of with you. Part of me is like, if they're unique, do I need to keep track? But let's just roll with it and see what happens. So far we have these arrays and our pivot defined. We are iterating through, or these are our temporary arrays. We're iterating through our main array and separating everything out based on its value in relation to the pivot. So things that are less are going to the left, things that are greater are going to the right, and if it's equal to the pivot, it's going into this equal array holder. That looks pretty good to me. But the next thing we need to do is we've divided. Now we need to print out each element in left, followed by each element in equal, followed by each element in right on a single line. And the output needs to be space separated. So again, if we think about, let's say we have this, I'm just going to drop our array in here. If anybody wants to talk while I'm typing, go for it.
Yeah, Chris, I was thinking about that equal because it makes sense to not have it, but at the same time, maybe it's just because of the data type it is, because it's an array also, and maybe it has something to do with the stitching because the pivot by itself is just an integer. I don't know.
Not true. Yeah, entirely possible. Good point,
I don't
Kelly.
know why they would ask us to do that otherwise.
Yeah, no idea. But definitely a good point. So we'll keep it here for now because it may have a use that we haven't really thought about. So that's cool. So if this is line 18 is our initial array, and we're saying that the pivot is going to be equal to 4. I'm just dropping some numbers in here so we can kind of see. Again, I'm a visual person, and we're going through our loop. What's this going to mean in terms of content for left and right? Somebody want to break it out?
Well, left is 3.2 and right is 5.7.
Okay, left is
3.2
3. Yep.
and right 5.7.
Awesome. All right, and then our equal is 4. Oops, that's all right. My mistake. All right, so what it wants us to output is something that looks like this. So it's going to be everything in left separated by a space, then equal, then right separated by space. So that's what we're trying to get to, and it needs to all be on that one line. So
we can iterate through each array and use a print statement.
yes. You want to walk me through it?
Sure. Left dot each do x print x. Does it add a space afterwards? I know it doesn't add a new line, but I'm not sure if it adds a space.
You know, we can test it out. We can go ahead and write this out and see what happens.
Sure.
Okay.
And of course, and the same for the equal and the right. So equal each. Yeah.
All right. And I'm actually going to comment all of this out. Actually, I'm not. That's one bad thing about the HackerRank interface. It doesn't comment as easily as anything that we use and learn. So, so I think we got everything that we needed to cover in the challenge. We've got, this is our standard input provided by HackerRank. We're breaking down our array, partitioning it, dividing it based on the values of the elements relative to a pivot, and then we are hopefully printing out each one of these contents, left, equals, and right, one after the other, all in one line, separated by a space. So let's see what happens when we run our code. All right, so it's telling me that we didn't pass this test case. It did compile, which is always a plus. Here's our standard input. This is what it gave us, and this is what we gave back versus what it expected. So we're close. We've got the right ordering. We're just missing those spaces. So what are you guys thinking we might be able to do?
I'm not sure if it's the most efficient way, but I would, in each of these loops, I would convert X to string and then add a space to the expression.
So like...
so dot to underscore S and then plus space. Yeah.
All right.
Exactly.
All right,
For
well,
each of those.
I have no idea what that's going to do. Sounds cool, though. What do you guys think? Anybody tried this yet? All right, that's cool. Tracy will try that one next. Oh, look at that. Congratulations, you passed the sample.
Yay.
Awesome. So yeah, that worked. Converting to a string, we had the spaces, and I see from the chat, Kelsey added print. She did some string interpolations, basically the same idea. So you can, if you open up the chat window, she went with this option. Oops. So just put the extra space right in there. So Kenlyn, you're my expert on efficiencies at the moment. Do you have any thoughts on which one is maybe better? I have no clue.
Oh, between the
Join
two?
would be better, honestly, just because it's built into Ruby and it's probably optimized.
Which one?
Well, neither. Probably join and use join on the space for each of those.
Yeah, I personally would have used like a join.
Okay.
Yeah, so like left.join and on space, and then just concatenate the 3 strings that you get. You wouldn't use an each loop. You would just do because it's going to iterate through. So left.join space plus equal.join space plus right.join space, and you would return that string or something. That may not leave a space between the 3. You might have to add those manually. But
Yeah, so maybe something like this.
Oh, you see
Yeah.
one more joiner on the right.
What's that?
You
Oh,
need another join on the right.
something like that.
Yeah, if that works, I think it might be efficient. How I would have done it was like maybe join all of them in one array, but then I guess to cut on lines. That if that works, then I would probably do that.
That probably would be, because then if you're iterating through each one again, you're looking at every single value one more time. But this one, it maybe, like, since you don't have to, it might be more efficient.
Yeah, I like your idea, William. That's a good one. Like set like a new local variable that's just called full array or something, and then equal it to the sum of all separate arrays. So like left plus equal plus right and then do full array dot join with the space in the quotes.
Like that.
And then flatten it or something.
Wait,
Or
like
is
when
it
you,
fine?
when you join it, then it'll have all the spaces in between it. I don't know if it will print it, but it's like the idea of it.
All right. Well, let's test them out. What do we got to lose, right? So bear with me while I manually comment. Our first option that we know works. This is the downside of the built-in compiler. All right, so double check, make sure I didn't miss anything. So now we're going to test out the output for, I think this was Scott's initial, where we're going to, I put this print in to make sure that it outputs. In fact, I should do that here.
Right. I think that one will, there won't be a space between, there'll be spaces between each array, but not between each element in each array, but not between the arrays. So I think it'll come out as like 3, 2 with spaces. And then, so I think the second, the print.
Yeah, I think you're right.
Print full array should work though.
Yeah. All right, well, it didn't cost us anything to try it. So let's just see what happens. And yeah. So that's exactly what happened. We got the space in, this is for line 29. It was exactly like Tadjo's thought. We got the space between left and the spaces in right, but we didn't get spaces between left and equal and left and right.
Yeah,
Or
we need to add like another like plus space plus or something like that. That's a long line.
I like this.
Yeah, if you wanted to do that, but the second one looks nicer. The full array one.
Let's see if this one will work.
Nope, didn't like that.
Nah, it's probably because I messed
Oh,
up.
there's a missing plus.
Oh, thank you. All right, so that works. So now let's try 31 and 32. Also works.
Oh, cool.
Okay, it's awesome, guys. So now what you would do, shrink.
I didn't know you could add arrays like that.
Oh yeah, yeah. What you can't add is what I discovered in the next challenge is a nil. That's a problem. So once you get something with HackerRank that passes, you want to submit your code. And because I'm lazy, I'm going to leave it with this version 3132 here. But I'm confident that these others will also pass. And what it does when you submit is it runs it against these other test cases. And a problem can have between like 4 test cases or 20 test cases or 200 test cases. And so if you have something that's not in your code that's not particularly efficient, you'll get that feedback because it'll, instead of having success, it'll tell you that you timed out or you got a runtime error or something like that. And I think, so if you want to see what the test cases are, you can purchase them for Hackos, which if you're not familiar, and I wasn't beforehand, it's kind of like Bitcoins. When you register and it's free to register, you acquire Hackos. So, and you get them very easily. It's just money that you spend, fake money that you can spend to get different solutions and test cases and so on. If you are logged in, just being logged in, you get a Hacko. So, so play with it. It's kind of cool.
This is an awesome site. I had heard about it before, but I've never actually checked it out. I'm like, this is great.
It is, but let me tell you, it's also humbling. So, so awesome, guys. That was pretty chill, pretty fantastic. Great teamwork, I think, getting through this partition one. So, is everybody cool with kind of how? And then takes my code away. You can go, as Tracy was pointing out when we started. You can go back and see your results. Gotta hide.
Does it measure in any way the efficiency of your code? Like, does it run it in like and the runtime versus other, like, so that you know whether you've written something that's like really inefficient or efficient, or
it does but it does so indirectly. So speaking from my limited experience, you're going to see the scores that come back. So when you start a problem, it'll tell you how much the problem is worth, and the points convert into hackos that you can use, like I said, is for whatever digital hacker rank things you want to buy. And the score is on some level based on the efficiency of your code. So when it runs these, go back to our results, when it's checking against these test cases, see how it's giving me a total amount of time it took, 0.02 seconds, 0.03, 0.02. Clearly there's a threshold that they've set saying your code needs to run these test cases in X time or less. And as long as you do, it's considered a success. You pass all of the cases, you get the full score. When I was doing it this weekend, and I can show you some of this briefly. I don't want to get too sidetracked. Go back to something that I failed at miserably. So you can see here I attempted this one, and I was able to pass one case. But these others, it timed out. So it took more than 10 seconds to run this one, so it just stopped. Here, I got some error 2.25 seconds into it. So I didn't get any points on this one, even though I had code that solved test case 1. I didn't meet the threshold. And all of these timeouts tell me that whatever I wrote was pretty inefficient. I don't know if that directly answers your question.
Yeah, it does. No, thank you. Yeah.
I just put something in the chat. There's something on leak code. If I just heard about it, well, I've heard about it before, but somebody just mentioned the other day that I guess you can compare your solution to others. That leak code, you can code it and then see how it stacks up against others.
That'd be cool. All right, and Tracy's saying that Code Wars might also do that. So someone's going to have to check that feature out there too. So, all right, so that was awesome. There are 3 challenges here. So in the 10 minutes we have left, did anybody have a chance to look at challenge 2 or this in-place QuickSort? I'll take the silence as a no, which is okay. So I'm going to say, let's start with this one, because I got stuck on this one, be perfectly upfront. This one builds on the last one, and we'll take the next 10 minutes to kind of go through it, break it down again, and it's probably time to move on maybe from this topic. So I'm going to suggest that let's see where we can go. And if you want to keep discussing this particular problem or different solutions or roadblocks that you may run into, let's do it in the Slack channel for the algorithms study group. Does that work for everybody? Yeah. Yep. Cool. All right. So one of the other nice things about HackerRank is when you see numbers like this, it's usually building. Oh, the other thing I should tell you about. They do rank, too much stuff on small screen. They do give you a ranking of difficulty. Take it with a grain of salt, but in relative terms, the easy ones are easier than the medium ones, and the medium ones are easier than the harder ones. So just bear in mind what someone thinks is easy for me sometimes is like, you got to be kidding. But anyway, so this one talks about starting how in the previous one you wrote this partition method, which we did, go team. We split it into smaller subarrays, and now it's saying, can you really get into the meat of what the algorithm is? So now it's wanting to introduce the recursion part and say, can you repeatedly use this partition to sort the entire array? And it's kind of doing a little bit more here. It says if a partition is called on, if you do it on one array, you get 2 arrays. If you then call the partition on each subarray, you get 4 arrays. And then I guess what the next one would be 16. So And you keep doing this, like I said, until your subarrays only have one element in them, and then they have to be sorted. Push it all back together. So now it's asking, can you do this? And the challenge here is every time your partitioning finishes, it wants you to print that subarray. And as a part of this is to kind of, I think, have that visual reinforcement of, oh yeah, I did just sort that out. So it's saying the first element should be the pivot, same as before. Wants you to do the left side before you do the right side. And then when you do the merging back together, just like we talked about last week, the pivot should be in between the subarrays. And then if you have an array of one or less, it's considered sorted, so you don't need to deal with it. This is kind of an interesting note if you look at some of the discussions, by the way. Just a quick side move. There are discussions, so you can see other people's solutions and so on. I'm going to show you these because you'll notice that the most popular language is probably not Ruby. So you're going to see a lot of Java and a lot of C++, but don't let it freak you out. There is some JavaScript, there's some Python. Python's very close to Ruby. So anyway. So it's telling you again, here's same as before. If we're going to get input, it's going to have the number of the array or the size, and it's going to have our numbers, and the output, it wants the partition subarray. So it's telling us if we're starting with a 7-member array that looks like this, it wants the sample output to be here, and then it kind of gives you a diagram of how it got to that. So again, kind of walking through it, we have the first element is going to be our partition, or our pivot, sorry. So then we end up with our left array and our right array. Right array. Then we're going to take the left array, take the first element, new partition, separate what's, or divide out what's left, new pivot, partition what's left. Next array, new pivot is 3. We're going to end up with a subarray of one element, which has to be sorted. So then it wants us to print 2, followed by the partition, followed by the partition, followed by the partition, and then you do the same thing on the right side, and that's how it's generating the output. So we're kind of good on this one, what we're trying to do? You're basically taking the method that we wrote in the last one, but now we're kind of bringing it into the big gun level, and we're just going to apply it recursively. And I can show you how far I got. I'm going to go ahead and run my code so you can see what it looks like right now. So my syntax, it's okay with my syntax. It's telling me here's my standard in, and I can get this 2, 3, but then my method craps out. And it's giving me this error because there's no implicit conversion of nil into an array. And I just want to show you where that error is coming from in hopes that this might inspire some of you guys to figure it out and fix my code. So, all right. So what I started with, I know I've got to write what I get from HackerRank when I first opened it are these lines and this def QuickSort AR. So I know I'm going to be writing this method. And I started out with saying, I don't want this to run forever because then I'm going to get those stack level too deep errors that we probably all have nightmares about. So I said, if I reach my base case, which is going to be an array that has fewer than 2 elements, so 1 or 0, just stop, return the array. Otherwise, here's my partition from the last method, or from the last challenge, probably looks kind of familiar. I'm basically saying, in my case, I didn't use equal. Here, I'll change that to make it look the same. Okay, so I'm using this built-in Ruby method called delete at. All delete at does is it removes the element at the array, removes the element from the array at the given index. So here it's removing element 0 from the array, and then it returns that element. So now, just to let me go back up here to our starter array. If my initial array looked like this, after this step, it looks like this. Okay, make sense? And I kind of like this because it takes the pivot totally out of the equation. I don't know if it's the best way, but it looks kind of slick to me. And then I'm just doing the same partitioning that we did before, where I'm taking each element in the array. Those of you who may not be familiar with this syntax, it's ternary if else. So this is the same as saying if element is greater than P, oops, I think I'm speaking differently than I'm talking. So it's basically saying if, is this a true statement? Is the element less than P, the pivot? If it is, shove the pivot into the, or shove that element into the left array. If it's not, if it's a false statement, shove it into the right array. So this is like your if condition, what to do, and then this is your else. All right, so that gives me my sorted array, and then I'm having a problem here. So in the time we have left, I won't bore you with how I went into Atom and so that I could use pry. But basically what I figured out is my code is crapping out when I get to here. Because if you see in this step, when 1 is the pivot, 3 and 2 becomes the right array. 3 becomes the next pivot. When I sort here, there's no values in the right array because 2 is going to be less than 3, and then there's nothing left to go on the right side. So my right value here, when I do this, is nil. And that's actually what's causing this error down here when it says you can't convert nil into an array. And I worked on this for a couple hours, and I can't see how to get it passed. But since this is being recorded, this code will be available, and hopefully one of you guys will be able to tweak it, to massage it, and get it to work, or maybe it'll inspire you to come up with something that will work a little bit better. Sound reasonable? Okay. One more thing I want to show you guys here, because these are, if you look, this is under practice, not under competition. So if you go to submissions, leaderboard, no, I think it's in leaderboard, and I've already unlocked it. Normally when you go here, this is going to say that it's locked. You can click, it's clickable, and it'll let you unlock and see all of the results. So you can see all of the people, 30s are just full scores, and you can see what language they use to solve the code, and you can look at their code. Just opens in another window. This particular one's in Python, maybe a bad choice, but the good news is when you get stuck, if you're willing to forego submitting for points, you can always unlock the current submissions, and you can find somebody else's code that's in your language. So maybe you can get some hints or some strategies or things, because again, this is just practice. And if you do a competition with HackerRank, you won't be able to do it, but I just kind of thought I'd throw that out there. So.
Are you able to submit your code and then come and look at this, afterwards?
Yes, I believe so.
Yeah, because that's cool. Okay.
Yeah.
That's great.
Because I was able to do that on the first one. I submitted, and then you can come back in and see how many other people did things with Ruby, for example, and if they did something in a different way than you did. So that's pretty cool. So we're 1 minute over, but hopefully this has been useful. I've enjoyed this. It's been very cool. And I know Kenlon and I have been talking. I kind of roped Tracy in a little bit too. We'd like to continue doing these kinds of study groups on a fairly regular basis. We were thinking maybe like every 2 weeks or so, not something that will compete with Learn, but something that can supplement it. But in order to do that, we needed some ideas for what you'd like next topics to be. If you wanted to do more algorithms, if you wanted to do more stuff like this HackerRank, where we pick a problem and maybe meet briefly to say, hey, this is the problem, let's meet back in a certain amount of time and kind of discuss and see what we were able to do. I don't want to put anybody on the spot right now unless someone's got a topic that they're just dying to work on. But maybe flip over to that algorithm study group and put a few suggestions in if you've got things you'd like to do, if you'd like to lead a study group. Even better, because it does help you learn stuff. You know, obviously to teach it back, you got to really know it well. So
I love the idea of, I mean, I would even do this weekly personally, but bi-weekly is great. Like where we pick some algorithm or something on HackerRank and we do some beforehand. We talk about it as a group. Like I think this is great because it is something that's missing in the curriculum. And as most of you probably saw, they're adding it into the in-person curriculum because it's such a part of the job market now. So this is great that we should all be really more into doing algorithms. So
I have to agree with you, Tatsuo. Sorry if am I saying that name right?
It's a tough name. It's Tajo, but I go
Tajo. My bad.
Hey, don't
Tajo.
worry. You wouldn't know. Don't worry.
Oh, okay. But yeah, I have to agree with you. I didn't know about HackerRank, and this is pretty legit. I mean, if we can do like sessions like this, I think it would definitely be really educational to just get the mind, you know, running and trying to figure out how all these sorts of different things like happen. So, yeah.
So how do you guys feel about every week then? Not make anybody want to run screaming or?
It's great. I mean,
I'm
there's a
good with
huge
that.
interest in this class, right? So even if not everyone could do it every week, I still feel like there'd be a good turnout.
Okay. So how about this? Let me, I'm going to put, does this time work for everybody? Is this a good time and day or move it around a little bit?
Today's Monday, right?
Yeah, I hope so.
Yeah, there's like usually not much going on Mondays. So really it's perfect.
I think it's perfect for me. Yeah, totally.
And this is something else. Like I'm taking a intro to algorithms course also, and I thought, because I did a lot of, I tried to do an internship over at Microsoft, so I did a ton of like mock interviews and like just like learning, and I think like cracking the coding interview and stuff like that. I mean, it's great. I love the framework. I love like just like how like really we do need to break it out as far as just how do we want to approach the problem first before we even start coding at all. But I felt like even that was a little bit too advanced for me to start with. So I don't know. I just thought it might be fun to throw in some CS topics every once in a while. I don't know if that would help anybody, but because it all applies to how we solve the problems and that's helped me think about it better. But number one is just practicing. I think the hardest part is actually just writing it down on paper and not Googling.
Yes. Yeah, definitely. All right. So I'm putting a couple of things back out there. For lack of other options, if Mondays I know everybody's in different places, we kind of settled on Monday 7 to 8 Eastern because, I mean, Kinlan got us moving and she's in Pacific time. So this was kind of a range when we were both available. If you'd rather do something other than Mondays, just send me a Slack and we can start moving some things around on times. Like Tajo said, maybe it doesn't always work for everybody every time, but yeah, we can move that. That's cool. And I see Holger's got a request for graph algorithms. You don't happen to know anything about that already, do you, Holger? He's still here?
Not really, no.
Not really. Okay. So I'll tell you what, why don't we maybe look for another problem and I'll post it to the algorithm study group in Slack and then create another group for this time next week. And we can go through another HackerRank problem. And then 2 weeks from now, hopefully we'll be ready to do some graph algorithms because I got to look into that too. If anybody wants to join in on graph algorithms and try and organize something for that. that would also be a good volunteers welcome. Sound like a plan?
Thanks so much to all the
Sounds
people that
good.
put this together. Yeah, thanks a lot. This is great.
Cool. Yeah, thank you.
Thanks, Chris.
No, that's awesome. Well, and yeah, thanks to Kinlan for getting us going, and and you guys for the great ideas, and Tracy for giving us a Zoom that doesn't conk out after 40 minutes. So, and I think she recorded.
I did.
Yeah, it's still blinking.
Awesome. So that'll end up being on the algorithms channel too, I hope. Right, Tracy?
Yes, I'll work on it.
Awesome. Thanks,
I
guys.
just solved the QuickSort too, so I'll post that in the Slack channel if you guys want to take a look at the code or something like that.
Yes,
Oh,
that would be
nice.
awesome.
That's Scott. That's
Right.
awesome.
And then I created a file that's pinned at the top that I'm starting to collect everybody's links and stuff. So there's also some of Luke's algorithm videos that he posted in there, as well as like all the notes from here.
All right, awesome. Thanks, Kinlan.
Mhm.
Cool. So I guess we'll see a lot of each other this time next week.
Okay. Sounds
Thank
good.
you all.
Thanks.
See ya.
Bye.